We are doing 2.2 power functions. So power functions are going to feel kind of familiar. They're kind of like one of the building blocks of a polynomial, but we're going to use some language with them that maybe you haven't seen. How is direct variation different from inverse variation? So, first of all, let's define what a power function is. Specifically, there's some rules that a power function has to follow, right? It looks like this. We're going to call it f of x equals k x to the n. So in this function, there's some rules. The first is k is a constant. K is the constant of variation. That's the language we give it. A lot of times we think of it as a coefficient, which is kind of nice. This is the power. N cannot be 0. It can be negative, but it is not 0. Notice x is the base of this particular exponent that we are working with. So some examples, because we love a good example, and we love a good non-example. So first, an example. 6x to the second. There's just a basic one, right? We can get a little bit fancier. Area equals pi r squared. And we can get crazy fancy and bust out, whoops, let me try that again. And bust out some chemistry. Volume equals K divided by P. P in this case is pressure. As pressure increases, volume decreases. As volume increases, pressure decreases. Okay? So in these, let's talk about this direct inverse variation. We haven't said anything about that yet. Well, this first example right here is direct variation. As x increases, the result increases. Let's look at this one instead. This next one is also direct. It is direct because if the radius increases, the area also increases. Okay? If I make my radius of my circle larger, in general, the circle becomes larger. This next one is called inverse. Let's get rid of the as. When volume increases, pressure decreases, or vice versa. If pressure increases, volume decreases, right? They go inverse of one another. I guess we could say the same thing over here. If we make our radius smaller, the area of our circle is also smaller. Okay, so those are some examples. Just really quickly, what's not a power function? Okay, anything with two variables, x, y, not a power function. You have to have your constant of variation. Anything where the exponent is a variable is bad news. And then if I have just like x squared plus 7, not a power function because now I'm adding in more pieces. Power function is just one thing. So there's some non-examples to hopefully clarify this language a little bit more. And you'll have the opportunity to practice that in your assignment as well. Okay. We're going to dive into... Now, you should be taking notes as we're doing this. Your first test was an open notes test, right? And it was set up, structured in a way that was meant to help you see the order as you went. So if you're not writing stuff down, I really wish you would get your poop in a group and grab a notebook and write some of this down, okay? The next thing we're going to do is some word problem practice. I'm going to walk you through a word problem example, okay? Now, if you're a slow writer, pause it. Okay, good talk. Gravitational. So in this problem, gravitational attraction A varies inversely as the square of the distance d. Notice we see two variables, which is great. The attraction is 2.25 when distance is 4. What is A if D equals 6? Now pause. Write that down. Write down key pieces of it. Write down the original formula. Just please write something down. Okay? I'm begging you. And now that you've written it down, now we can go in and dig into it a little bit. Because, oh my gosh, the words are so important. Attraction A varies inversely as the square of D. So I'm going to come back up here real quick. Inverse variation means that we're doing some dividing, right? Inverse variation involves dividing. We are multiplying when it's direct. As the square of the distance, D. That D, whoops, my bad, I got a little crazy with my eraser. That D is going to be important. Here's what I mean. Let's take those words and start writing some stuff down. A equals. Attraction varies inversely. A equals some relationship over here. A equals K. We always are going to include a K, but since it's inverse, we are going to divide by the variable D, but not just D, as the square. Super important word. As the square of the distance. So not only am I dividing from the word inverse, I'm dividing by D based on the order of the sentence, and I'm dividing by D squared because that word square in there. Okay, so now I have to figure out what the heck I'm going to do with this. Well, the first thing is I need to know what K is. So here we go. Find K. A equals K over D squared. Dun, dun, dun. Great. A is 2.25 when D is 4. Oh, well, now I've got just one variable left. And I can solve that K is 36. Why does that help me? Well, because now I can come to this equation and I can say, actually, A equals 16. My constant is 16. Okay? And so now I can actually solve this because I know enough. A equals 36 over D squared. Well, D is 6. A equals 36 over D squared. Oh, hang on. I don't want D again. I just said A is 6. A equals 36 over 6 squared. Well, that's 36 divided by 36. Oh, so my attraction is 1. So it's a process. I'm given enough to find the constant first, and then I use the constant, right? So the first thing we did was, what is the constant? And then after that, we use it to answer the question, right? Because what is A if D is 6? A equals 1. Okay. Changing up the language here a little bit. Not changing it up, but we're adding to it. We're about to be smarter. So up at the top, we talked about what a power function was. We're going to modify the language a little bit and say this. A power function, we know what those are. We talked about those at the top of our notes, where K is a constant and N, let's put N on the next line, and N is a positive integer. So now we got a couple key specifics. It's called a monomial. Oh, I know what that word means. Mono meaning one, meal meaning term, one term, right? Binomial, 2 terms. Trinomial, 3 terms. Polynomial, many terms. Poly meaning many. Anyway, back to our good old examples and non-examples. Here's an example of a monomial. Pi r squared. Ooh. Pi is the constant. The exponent n is an integer 2. 6x squared, the one we used as our previous example. Negative 3x to the 9th. Some non-examples. X to the 1/7. Why? 1/7, not an integer. It's a fraction. It's a problem. It's positive, but it's not an integer. Look at another one. K, p to the negative 1. It's an integer, but it's not positive. And then last but not least, 2 to the x. That's not even a power function.